And I'm gonna show you the operation for vibrating wire readout unit. Here basically we have a piezometer connected to our unit using those alligator clips. So here we can see the measurement of the frequency and temperature. We can change the temperature unit using this button. So we can change it to Celsius degrees or Fahrenheit. Also we can change the measurement of the frequency. So we can change the units of the frequency to hertz, to microseconds, and to digits. This unit corresponds to hertz to 2 divided by 1000, if I'm not mistaken. So we have a GPS. The GPS is used to update the timestamp of the unit and also to provide the information of location in case we choose to store the data. So using this floppy disk button here, we can store the measurement. The question that you just saw here, it's because the GPS is not locked yet. Once I just powered on the unit, the GPS takes about 2 minutes to find the GPS signal. So when we try to store the measurement without the GPS locked, the unit asks me if I really want to proceed with this operation or if I want to wait until the GPS locked and then store the measurements. So besides the GPS and the logging functions, we also have here a list of up to 32 sensors that we can previously configure. So using the USB connection, we can configure some parameters for this list of 32 sensors. So for example, if I know that I will take some measurements from certain sensor, I can previously insert the information of calibration factors, offsets, and other informations in order to acquire a different measurement here. For example, we can we can convert the frequency to meters or any other unit that the user may want. So to do that, we just need to plug the unit to our PC, configure the list of the sensors, then we just choose the corresponding sensor here, and then the sensor that I choose will be shown up here, and their calibration units there or any other parameters that I inputted in the system will be used to convert the measurements here. So we can also perform a zero reading. So using navigating in the menu, we can perform the zero reading. That means that for this sensor that I am reading right now, the measurement that I'm seeing here will be used as the zero parameters. So the zero reading will be performed here, and this information will be used in the equations that I just configured previously for this specific sensor. On the menu, we can change the date and time. So we can basically change the timestamp if we don't want to use the GPS. We can select here if we are going to use the GPS or no, or not, yes or not. So we can also change the power settings. This is automatic power off of the unit and the backlight time. So we can change both parameters here. And finally we have the zero reading. This is basically the operation of our unit. So it runs using an internal battery, so we can use it up to 40 hours continuously using the GPS, or up to 80 hours without using the GPS. So the unit uses IP67 parts here. The enclosure and these connectors here are designed to be IP67 rate. But because the label here, we actually have a IP66 rate for this unit, so we can use it under rain or even under some severe weather condition. I'm gonna show you the display outside. Here you can see that even under a sunny condition, the display has a really good contrast, so it actually works better under the sun. So this product is really designed to feel the operation. You can see here. So this was the basic operation of our unit. I just forgot to mention that the battery is rechargeable, so we can recharge the battery using the USB cable. And I also just didn't mention that the GPS LED stays blinking when the GPS is not locked, and when the GPS finds a good signal, the LED just turns constantly on. So here, for example, now we can save the measurement without that message asking me about the GPS.